All right, folks, welcome back. Day two, huh? So for us today, what you're going to see here now is I want to clean up a little bit with field lines. There were a couple mistakes that were made on your homework and worksheet stuff from yesterday that I do want to go through and fix with you, just so that you can see what's right, what's wrong. All right, I'm going to talk quickly about magnetic domains. Not a huge thing for us, really kind of a difficult thing. And then today's assignment for you is going to be Lab 15.1, Mapping with Me. I'll show you how to do that in a little bit here, and then turn you loose on another Schoology assignment. Again, let me know if you're having issues with that stuff. I got emails from some people throughout the course of the day and hopefully fix that stuff for you so that it was easier to work with. All right, here we go. All right, so which compasses are correct? Now, if we're looking through here, remember that our lines always go from north to south. So what you have here is you have the field lines already drawn for you. All right, so if we go point by point, A is going backwards. You can't have it leaving north and then as part A shows coming back into north. That's not right. All right, part B is perfect. Yep, going straight away. Eventually that thing will make a left hand or a right hand turn and come back, or it'll just keep going on forever until it hits another spot where gravity will pull it in. Part C also works. The end is a little bit straighter than I would like it, maybe necessarily, but again, it is going in the right direction. Part E is going perfect as well, just like we wanted to, going flat towards that south end. Part D, sorry, it's not going to make a right hand turn that drastically right there. Part D is not right. Part F, nope, going the wrong way. It's not, it has to be going towards that south end for us. That's the way it's going to be attracted to. Part G works. Again, the angle is just right. Part H is opposite of part E, so part H would also be incorrect. All right. So just for your reference, B, C, E, and G are all four ones that are correct for us. Okay. Magnetic domains. So magnetic domains are these tiny regions in the magnetic fields where the atoms are all lined up. What we mean by this is we're talking about a very small area for us. So when we see something that's unmagnetized, if you notice the direction of each one of those little compasses, all right, or compass if you want to go that way, whatever you want to call it, what you're going to notice is that you're getting some that are actually canceling out, meaning that they're going opposite directions of each other. By doing that, what happens is that that material gets confused and it cannot be drawn or moved or done anything like that with a magnet. This would be unmagnetized, okay? If we go to an actual magnetized material, then mostly they're in the same direction. What you see here is a couple towards the bottom are going a little bit different than the other ones, but for the most part, what you're seeing is that everything is going to track in that same exact direction. Now, the way to make this more magnetized would be to have all of those arrows exactly parallel with each other or following each other in the same line. That's going to make it even more magnetized. This one is still going to be magnetized, but not as strongly as we can make it. All right. So when we see this, this is the difference between the two. So as we look, we'll see here the left side magnetized, right side unmagnetized. Again, the reason why the right side is not magnetized is simply because you got arrows going the wrong way. You got arrows going down, you got arrows going up, you got arrows going left, you got arrows going right. On the left side, there's a little bit of a difference in some of those bottom ones, but for the most part, what you're going to see is that those are traveling all in the same direction. This is really where we're looking at. We're looking at a microscopic level. So you can see in the bottom right corner, this is 20 micrometers, right? So we're scaled way in. And what we're able to see is that some of these striations, some of these changes in this material allow it to be magnetized versus not magnetized. All right. So just kind of your real world example for us. All right. So how do we change this? So if we want to return the magnet to its disordered state, the first thing we can do, hit it. You know, if you hit a piece of magnetized material hard enough, it'll shock the domains back into the organized state. Now, here again, we don't want to necessarily take like a kitchen magnet or a neodymium magnet or something like that and smash it, right? Because what we're going to have to do is we're going to have to apply a huge quantity of force to get this thing to go from being all in the same direction to being all in different directions. All right. But typically that's one way you can change this, I suppose. If you're going to a scrap metal yard or something like that and you saw the big electromagnet and you wanted to, you know, affect that magnet somehow without actually shutting the electricity off of it, you have to hit it really hard with something. Okay. The other way for us is heat it up. Once you heat it up, the material then starts to move around a little bit and the domains will disorganize. Again, as we heat it up, we want to turn this thing into almost a liquid state. So that stuff can move around. As it starts to move around, what happens is those little plates then disorientate themselves, and all of a sudden now you have something where you're going to see that it's going to be different than it was before. All right, it will make it so that it's nice and unmagnetized for us. Which, if that's something that we're looking for, that's something that we can get done. Okay. All right, for lab today, this is what you're going to do for me. All right. Um, Lab today is going to be pretty simple, pretty basic for us. What you're going to do is you're going to first follow a video watching me do this. All right. The way that I'm going to do this is I'm going to lay out a bar magnet on a sheet of paper, and I'm going to put a compass next to it. I'm going to follow the path of that compass as it goes farther and farther away from that magnet and see does it come back to the other side. All right. At the end of all of this, what I'm going to then do is I'm going to connect those lines or those dots. As you can see here on the right side of the screen, I got a compass sitting there. It's going to have some dots like that. Just going to go compass point to compass point. The north end of this magnet just so happens to be the gray one. The blue is the south end of it. So I'm going to repeat that one after another until it hits it. I'm going to draw 3 lines on each side. So for a total of 6. What you'll find out is that you have to also do this through the Google Doc. Okay. So here's what I'm going to have you do. I'm going to have you follow me over to the next video. Next video will contain the kind of me drawing this so that you can see what it looks like. All right. So we'll see you over there in just a second. Bye-bye.